I thought, oh, you're doing distribution, or you're doing area model, right?
Yeah.
I'm doing distribution, my bad. So, we'll talk through Keyshawn's area model in a second. When it comes to distribution, personally, I'll go ahead and tell you, I recommend the area model. But this distribution is something you probably saw in Algebra 1. Don't forget, one, y'all have color, or you have the boxes on your desk that have colored pencils and things in them, right? Yeah? You can use those to help color coordinate different things like, okay, here's my value or my variable x, and I'm going to distribute that x. Yeah. Okay? So, I'm going to color coordinate and show x being multiplied. One, notice how I'm using arrows. Hey, I need y'all to stop talking, pay attention from now while I'm teaching. I'm showing an arrow of x being distributed to that 5x, but don't forget they're being what? Multiplied. What is x times 5x? 5x squared. Notice over here with Keyshawn's method, right? X times 5x gives him 5x squared, right? They're not different, they're the same, just showing it in different ways to help you. Now, x times 1, 1x. Notice, x times 1 gave 1x there. Then, again, you can color coordinate if it helps. 2 times that 5x gives what? 10x. Did Keyshawn also get a 10x? Yep. And then 2 times 1 gives me 2. Alright, so the 2 right here as well. The area model, legitimately, ladies and gentlemen, is just a organizational tool to help you see all those different terms being multiplied and distributed out. I will say this, personally, because this is the way I was taught, if I have just 2 binomials like this, by the way, what type of function will this result in?
Quadratic.
Quadratic? What? It's 2 factors, right? So it has how many zeros? 2 zeros. Now, one thing to clarify, this is a side note, don't write this down. What about if I had x squared minus 4 times x plus 1? What type of function would that be? So we want to recognize it's a quadratic times a linear, which would give us a cubic, right? So it matters what degree is inside of each factor, okay? It's not just how many factors there are. But if I'm doing 2 binomials, I'm probably going to distribute. Distribution is pretty easy when it's just 2. But when we get to higher things, like if I had this, is that a lot that we would have to distribute? Could the area model help us organize all of that? So can you change methods midway through? You can. It's up to you. Right? I'm not going to tell you which one you have to use. If you are like, well, but Mr. Kinney, if I'm going to use the area model here, so I'm just going to always use the area model, cool, go for it. I'm fine with that. It'll work. If you are comfortable with the idea of switching from distribution to the area model, go for that. If you just want to do just distribution the whole way, go for that. It's your choice. Pick your poison. Actually, it's not poison. Pick your favorite method. So 5x squared plus 11x plus 2. So, same answers? Yes, Mr. Kinney, we did get the same answer. Bet, thanks guys. So be careful, right? Not sure what happened with the 10x here, but we got a 10x there. Be careful right here. I don't know if this student noticed, but they actually wrote the entire latter part of the expression just in the exponent. So be careful when you do that. And then also be careful here. It's not 10x times x. I don't know where it just went. But it wasn't 10x times x. Remember, the one thing to be careful about with the area model is we multiply these binomials, but what are we going to do with these terms? Add them. Just like we're adding here. Right? Each of the terms are being added. If it's positive, it is being added. If it's a negative, it's being subtracted, right? Adding and negative is the same thing as subtraction. One thing I will point out, just because I think this will help you create your area model better, okay? What I would always do first is I would just draw the box, And then remember, how many factors can you multiply at a time? Just 2. So I'm going to create a top row, I'm going to create a left column. And don't forget, what operation should we put here to show what's happening? We're multiplying. You can do other operations. This is to help us recognize we're multiplying. Then I'm going to write out my terms, right? I've got an x and a 2 for that first factor, and then I've got a 5x and a 1 for the second factor. Doing it this way can help me account for, well, if I have 3 terms like this, how many rows would I need? If I have 3 terms, how many rows would I have needed? 3. So don't forget that you need a new row or a new column for each term. And so that's something to pay attention to. What are your questions, comments, and concerns before we continue from 2B? Yes, sir.
So you add a row right here, do you have to also add a row right there?
You do not. That's a great question. So let's say that I was taking this 5x squared plus 11x plus 2 and I were to multiply it by, making something up, x minus 3, right? Well, now I'm not going to want to square because one is bigger than the other, but you can if you want to. But remember, I have one factor here and I have one factor there. For x minus 3, how many terms are there? Not one. So one thing to be clear about is the terms are separated by addition and subtraction. So there's one term here, and there's one term here. Does that make sense? So I've got an x, and I've got a negative 3. I don't need anything else. I don't need another column, so I just split them there. Okay? But if I look at this first one, right, I need a 5x squared, I need an 11x, and I needed 2. So I needed 3 rows. So it depends on how many terms you have. Okay? Now, I did this one vertically or oriented vertically. It doesn't have to be that way, right? I just need one on the left, one on the top. Notice I have more space up here. So in this case, I would probably do 5x squared, 11x, and a 2. And then I would do my x and negative 3 here. It does not matter which way you orient that rectangle. You just need your 3 terms and your 2 terms to organize that distribution. Does that answer your question? Okay. Remember, the order that you multiply doesn't matter, but you can only do how many at a time? 2 at a time. Questions, comments, concerns? Okay. So this is the procedural side of it, multiplying it out. Hopefully we understand how to fix it if we put 10 or something else. One thing I do want to point out is that my bet is if we got this 3 here, my guess is that we did 2 plus 1. But remember what's happening between those binomials. They are being multiplied, right? So it's 2 times that 1 to get that 2 there. Yep. So pay attention to that. We're going to get some more practice with this today. Before we get to that more practice though, I got one more poll question for you because I want you to think about this. So please note, a lot of students miss this detail. This question is asking about 2D. 2D in your textbook. We're looking at 2D on M177. If you want to talk it out with your group, that's good active collaboration. You need to do some push-ups, get some blood flowing. Don't fall asleep while we start doing some push-ups. Now, I would recommend doing jumping jacks, but you're doing some physical movement to stay awake. You can't do push-ups or jumping jacks? Why not? That's too frail. Get out of here. What do you think is cute? You know we're looking at D, right? Huh? You got 20 seconds to select an answer. Remember, I'm not asking you to do all the work, I'm just asking you to decide what type of function this would be.
Did we look at this? Do you think
I'll
it
put
is?
cubics. Okay, but here's the thing,
Over there, right?
Because for D, we have 2, right? We have 2 zeros for the original. At the end, we have 3
Oh,
zeros.
okay.
But I don't like that. I like that. Distributive. It takes like 5 seconds.
Oh, I see.
It's not.
I think you like that one. It takes like 5 seconds.
Is it a lot?
Okay.
So you do like. Skip the general.
Alright, let's talk it through. The vast majority of us are talking cubic, and I heard some great reasoning that I want to pull on instead of just me saying this. Again, most of us thinking cubic. Liam, I heard you talking with your group pretty heavily. Why were you thinking cubic for this x plus 2 cubed?
He was not thinking cubic.
Oh, I thought I heard you saying cubic.
I was
No.
Oh, you're thinking
He
exponential.
was thinking exponential.
You said exponential. Tell me why you were thinking exponential then.
Well, I went back to B because B we started out with 2 zeros.
Uh-huh.
But yet when we did all the equation and everything, we ended up with an extra 0.
Okay, so here, you're talking about with B, we started out with 2 zeros.
Mhm.
Does anyone want to push on that language a little bit, or maybe ask a question about that idea?
Yeah.
Remember, those are 2 factors. Now, those 2 factors are going to have 2 zeros, right? So there are 2 zeros there from the 2 linear factors. We don't have zeros yet. Okay? So continue your discussion from there.
Well, from there, we did, we pretty much multiplied them together, and we got another 0 pretty much, which was the 11x. So that's why I'm saying if we have a cubic here, when we do all those and everything, it's gonna end up exponential.
Okay?
That's just my thinking.
That's your thinking. So, let me ask that question. Would you all agree that we ended up with a new 0 once we distributed? No? You don't think 11x is 0? Why not? Okay,
I'm just
but,
saying
and that's
too.
fine, but if it's a mistake, we need to address it so that we can fix that mistake. Guys, remember, I'm not asking y'all, and I'm not saying he's right or wrong or anything like that. I need y'all to talk out loud so that I can hear discussions, so that I can pull on it, we can talk about it, and if you got a right idea, we can emphasize it so that everyone else hears it, or if you're making mistakes, that way we can address it. Your active collaboration and discussion should be driving the classroom. Talk the ideas out, ask questions of each other, ask questions of the whole class. Now, one thing I do want to remind you is, a 0 comes from the idea that the function is set equal to 0, right? So what do we always set equal to 0? Not terms, but the factors. So remember, the factors are the only place that we find our zeros. Okay? Does that make sense? Now, I will point out there is something in the standard form that tells us how many zeros there's supposed to be. Now, this is 2b, not 2d. We'll get to that in a second. What here tells us how many zeros this function has? The highest power, which is the degree. So remember, the degree is the highest power. So notice, did we create a new 0? No, we still have 2 zeros from those 2 factors, right? Now, you said then that it's going to be exponential. Does anyone want to push back on why they think that it might not be exponential? Because most of us said cubic.
Well, isn't exponential like a degree of a variable, not a...
So remember, and that's a great point, right? If we have an exponential, the exponent is a variable. We can transform it or something like that, but no matter what, when it's exponential, the variable is in the exponent. Notice, what would this be indicating by rate of changes? The 2 is being multiplied, so we're repeatedly multiplying by not x, by 2. So remember, the idea of that variable being in the exponent is that we can change how many times we're multiplying by 2. That's a multiplicative rate of change. So to have an exponential function, the variable is in the exponent every time. When the variable is in the base, we're looking at a polynomial. So a lot of us said cubic here. Anybody want to share why they thought cubic on this function? So, because of the degree? Okay, so where do you see the degree though?
When you distribute the power of 3 of the eights and the 2 the highest degree.
So are you thinking that so you're saying distribute, so you're thinking that I would get x cubed plus 2 cubed, which would be x cubed plus 8? That's what the function would be?
Wait,
Yes? Maybe? No? Seems right. So I'm going to come back to that detail in a second. Regardless though, we are cubing that x at some level, right? So what kind of function would it be? Cubic, right? What I would point out is, remember, if we're cubing, what does that really mean?
x times x.
Not x times x times x. X plus 2 times.
X plus 2.
We need to be careful and remember that. So we're going to talk about the difference in a second, but I want to emphasize and remind you, we are now multiplying 3, what type of factors? Linear. Each linear factor has a degree 1. It each also has a 0. So how many total zeros are there? Kind of.
3.
Right? So it's going to be a cubic. Now I say kind of with those zeros. We'll talk more about that in a second. So again, the idea of 3 linear factors tells me it is cubic. I bring up linear factors because let's say I had x to the second plus 2 cubed. Would that still be cubic?
No,
No,
that'd be
3
But it's 3 quadratics, so what degree?
8.
Not 8,
6.
6.
Ah.
Notice that'd be x squared plus 2 times x squared plus 2 times x squared plus 2. Remember, this is quadratic, so how many zeros does it have?
2.
This has,
2.
so that's 4. This has, so that is 6. Okay? So keep in mind that we need to pay attention to, is it linear, is it quadratic, things like that, because the zeros and the degree always have to be the same. What tells us that the degree and the zeros are always the same?
0.
Not zero product property. The what? Fundamental theorem of algebra. The fundamental theorem of algebra is what tells us an nth degree polynomial has n zeros. Now when we count the multiplicity, because remember, that multiplicity can matter. So that's something to keep in mind there. Questions, comments, concerns about 2D and why it is a cubic? Good?
No.
Good? Juanicia? Yeah, Sheridan? We good? Jesus, Mackenzie? Jakeem, Tamia, y'all good?
I have a question.
Say again.
I have a question.
Alright, what's your question?
So what kind of degree is exponential?
So an exponential is not a degree. Degrees are only for polynomial functions, right? And so notice when it's a base raised to a power, that's when you have a degree. That's a polynomial function. 2 to the x, that's exponential. It does not have a degree. You good with that idea? So that is a good point and question. Please be aware, degrees only apply for polynomial functions, no other function. So when it's x raised to a power, that will have a degree. Okay? Other questions, comments, concerns? That was a great question. All right. Let's go back to the slides. Now, yeah, actually that's a great place to start. I'm going to come back to this detail. about what Kloe was talking about, if x plus 2 cubed is equal to x cubed plus 8. We're going to look at our objectives first quickly though. Start on 4.3, multiplying to create polynomials. Remember, we have an understanding check at the end of the day, so we need to move, we need to practice, we need to get that experience in. Yeah, Jaquan. Alright, so what we're focusing on right now is partially this, practicing building cubic functions from linear and quadratic functions graphically. We're also doing it algebraically. We're connecting the characteristics of these functions to their factors, but really this is the big one. We're showing how linear, quadratic, and cubic functions demonstrate the fundamental theorem of algebra. So this is what we worked on or started with yesterday. Do not forget, how many factors can you multiply at a time? 2. And this area model is just one way to multiply them. Alright? The other way is this distribution. It's your choice. Alright? You decide what's best for you. We completed A earlier. We already did the algebraic for B. Now, I want to emphasize this because we're going to use this on 2D in a second. How can I check, because I don't think we've done this yet, how can I check to make sure that 5x squared plus 11x plus 2 is in fact the same as this factored form? Do not forget that. We always want to check our answers by graphing our functions, right? So, by the way, don't forget, factored form to standard form, all you're doing is what? How are we going from the factored form to standard? Distributing. So there is the dilation. So, Chloe, remember there is dilation right here, but it's actually the multiplying it out or the distribution that gets us to the standard form. So if I ever ask for standard form, that's what I'm asking you to do. So let's check. And I'm going to do this quickly. You'll do it on your own in a second. Note, I'm going to add a page, graph. Okay, so we started out with x plus 2 times 5x plus 1. There it is. And we ended up with 5x squared plus 11x plus 2. So what do you think? Same function? Does anyone remember what the mathematical term I used yesterday?
Yeah.
There we go, right? The factored form is mapping on top of that standard form. Look at Jaquan getting engaged there. It's like he learned stuff even though he's like, Mr. Kenny, this is the worst class ever. Now you learning, you growing, and I love it. All right, so we got our factored form, we got our standard form. I can't even see both of the curves because one maps directly on top of the other. They are the same function, so we did that correctly. We all good with that detail. So let's check Chloe's prediction about the x plus 2 cubed being the same as x cubed plus 8. So I want you within your small groups, I want you to do graph the x plus 2 cubed. So graph that function, right? Graph the x cubed plus 8. And let's check to see if they are the same function. Where's your graph? You haven't even checked. If you go to menu and you go to Windows/Zoom, Zoom standard. Okay, so graph those two functions in there. Wait, no. X plus 2 cubed and x squared plus 8. X to the third, yes. Yeah, why'd you do 2 there?
No.
You're looking at the wrong one. Guys, sorry. This over here is what we are graphing, not this purple. Remember, that was a different example. No, it's not the same? No. So, x plus 2 cubed. Actually, before I hit enter, I want to ask you, does anyone know what the parent function is here? It's cubic, right? Remember, what creates the transformations? What operations? Multiplication, division, subtraction, and addition. So when I look at y equals x plus 2 cubed, The only thing creating transformation is this plus 2. So what's my parent function? X cubed. We good with that detail? Now so I'm just going to quickly graph it. 0 cubed is 0. So an x value of 0 has a y value of 0. What's 1 cubed? 1. What's negative 1 cubed? Negative 1. Negative 2 cubed to be negative 8 somewhere here. 2 cubed to be a positive 8 somewhere here. That's my parent function. I bring this up because that's what x cubed looks like. I want you to think about this function. What has happened to this parent function right here?
They moved to the left.
Okay,
Translation.
so instead of saying moved, right, it said translation,
Horizontal translation.
horizontal translation to the
Left.
left. How far? 2.
Two.
What's happened in this function?
They moved up.
Hey, Tyrese, thank you.
Translation to the.
Translation. So it's a vertical translation. Remember, if you aren't clear on this, this is horizontal because it's inside the main or defining operation, right? Everything on the inside is horizontal, and everything horizontal acts the inverse, right? It is opposite in this case because it's addition, but if it was multiplication, it would not be the opposite, it's the inverse. So that's why it's to the left. But this would be a translation up 8. So I just want you to think about that logically. Should a translation left 2 and up 8 give you the same thing? Let's check it. So there's to the left 2, right? And then I have x cubed plus 8. That's odd, I can't even really see it. Okay, so let's see. There it is, right? You see how that was translated up 8 from the origin, okay? I need y'all to hear me very clearly on this. Kloe just made the most common mistake. I see it out of probably 75 to 80% of students, and it's one of the most beautiful mistakes so that we can all learn from it. I love mistakes. Make all of them so that we can learn and grow. Do not forget, all right? Because here's the thing, right? Y equals x plus 2 cubed. Notice how Kloe talked about distributing that cube there? I hope so y'all noticed that. Do you know what operation distribution only works with? But what happens between those parentheses?
Multiplication.
Multiplication, right? Distribution only works with multiplication, and because division's its inverse also with division. You can only distribute with multiplication and division. Don't forget, what does this cube actually mean? You're multiplying what 3 times?
Constantly adding.
Well, no, remember an exponent is constant multiplication or repeated multiplication. That is what you need. Students make that mistake every single time. Please learn from it, grow from it, and don't make that mistake moving forward. Mistakes are amazing, especially when we learn from them. So, you're going to have to use either distribution or the area model to actually multiply that out. You will, I will say, get an x cubed and an 8 on the ends, but there's a lot in the middle we're missing. We'll come back to that in a second. Alright, from here. Do what?
I said, to be fair, nobody pushed back.
I know! I'm not saying that it was just you, right? That was your prediction, and I love that prediction. We learned from it. No one pushed back on it. So, was that a mistake we were all making?
No, sir.
Wow.
Yes, sir. I was making that mistake because I wasn't pushing back on it. Alright,
Just
so.
wanted to embarrass Kloe.
Oh, that's what it was, So-
It's not a mistake if you never did it in the first place.
It's true. If you never even tried, you're not better than making that mistake, right?
Exactly.
Making a mistake when you try is always better than just not trying. Alright. Bring it back in, bring it back in. So, number 2, right? We've already done the first part with 2b, determining each product algebraically. Show all your work. We did that. Did we use technology to verify this product is the same as the factored form? Yes. Now, y'all need to get to the part where we're sketching the graph and explaining how the function demonstrates the fundamental theorem of algebra, right? You have a little graph there. Do not forget, right? When we are doing this, what's the first set of points you really want to pay attention to? the zeros. Whether you're doing a sketch like here or being very accurate like how we're going to do on the understanding check today, you need those zeros first. If you're just sketching it, what are some other points that you want to pay attention to on the graph? Like on your graphing calculator?
Relative max and min.
Relative max and min to help flesh out that sketch. So, I want y'all to work on 2B. We should be able to finish 2B in probably the next 4 minutes or so. So I need y'all working actively, talking it out. Then move on to 2C and 2D. Let's get to work. Nuh-uh, you still need to do this part of 2B, sir. You still need to do this part for 2B. Alright, so talk about it with your group. I'll be coming around checking in on everybody. Huh? Okay, but hold on. With your sketch, how did you get your points? Yeah. So you got that, but how'd you get the sketch? Because I don't see your. Yeah, so my guess is you just looked at the calculator and didn't actually.
I think I did figure it out, but I didn't write it down.
Well,
And then I put it in.
you need to do that. Okay, look. When I first look at this, what are the first set of points we really need to pay attention to? And so you need practice identifying those zeros. So how am I going to get my zeros? X plus 2 is equal to, right? So remember, the whole idea is that the whole function equals 0, and from the zero product property, each factor would be set equal to 0. So solve for x and get those zeros that we're going to graph. And then what's the other major point that we need to pay attention to? Relative max and min, which that's you're going to have to pull off the calculator. Okay? So get your zeros, graph your relative max and min on the calculator.